Google's Project Suncatcher, space-based AI data centers targeted for 2027 prototype. Google unveiled a research plan to trial space-based AI data centers by early 2027, betting that near-continuous solar energy and vacuum cooling could offset Earthbound power and thermal constraints. The Guardian and The Verge outline clusters of satellites in low Earth orbit equipped with TPUs and laser interconnects. Google's own research blog frames Suncatcher as a modular constellation linked by free space optics, noting solar productivity in orbit can be up to 8 times that on Earth. Challenges include radiation hardening, thermal management, terabit-class downlinks, debris, and governance questions. If feasible, a hybrid architecture could emerge, terrestrial edge capture with burst compute in orbit for specific workloads. Policymakers will need to tackle spectrum, export controls, and cross-border data rules, literally above borders. Google unveiled a research plan to trial space-based AI data centers by early 2027, betting that near-continuous solar energy and vacuum cooling could offset Earthbound power and thermal constraints. The Guardian outlines low Earth orbit clusters equipped with TPUs and laser interconnects, while The Verge details radiation tolerance tests for Trillium-class TPUs and a joint mission with Planet for 2 prototype satellites. Google's own research blog frames Suncatcher as modular constellations linked by free space optics, with a cost analysis suggesting potential parity with terrestrial energy costs by the mid-2030s. Significant hurdles remain: radiation hardening, thermal management, terabit-class downlinks, debris, latency, and governance. If feasible, a hybrid architecture could emerge, terrestrial edge capture with burst compute in orbit for specific workloads. The project also raises new policy questions around spectrum and cross-border data rules, literally above borders. Google unveiled research plans to trial space-based AI data centers by early 2027, betting that near-continuous solar energy and vacuum cooling could offset Earthbound constraints for power-hungry AI workloads. Reporting from The Guardian and The Verge outlines clusters of satellites in low Earth orbit equipped with specialized processors and laser interconnects. The concept faces steep challenges: radiation hardening, thermal management, terabit-scale downlinks, orbital debris, and regulatory sovereignty questions. Still, falling launch costs and the environmental burden of terrestrial cooling make the idea more than sci-fi. If feasible, a hybrid architecture could emerge, edge data capture on Earth with burst compute in orbit for certain inference training tasks. For cloud buyers and policymakers, the project tees up new conversations about spectrum, export controls, and cross-border data governance, literally above the border.